calculator. Excuse me? Shut up.
Mr. Stein,
What's wrong with
I know how to do it, but like, do we divide those first? Do we divide it first?
You're going to multiply the mass times the percent, just divide by 100. Because you can't multiply times percent. That's why you have to divide by 100. So if it's 48%, you have to say 0.48 times the mass. What does the electron control in the atom? Starts with a B. Yeah, you might want to write that down. It controls the behavior. So the elements basically are grouped based on their behavior. You have the alkaline, the halogen. So we group things based on their behaviors. What are they going to do when they react with other things? Basically, there are only 7 groups in the periodic table that are predictable. So we like to predict things. That's what makes chemistry reliable. If I can predict your behavior, that more likely will help me, I guess, be more confident in the results if I give you something to treat you for an illness. Make sense? Or if I'm trying to make a product, if I can predict its behavior better, I can expect the outcome, expect the results better. So up here, the electrons are associated with predicting behaviors. And we have specific shapes where the electron's going to reside as far as on its outside energy level. We really care only about what's happening on the outside because those are the ones that tend to gain and lose. And if you're gaining and losing, that's a behavior we can observe. Does that make sense? The gain and loss of electrons? That would be behavior. So I want you to color the different main groups. So this is the S block. Just pick a color. And I want you to color the D block and then the P block. So we're going to color code the periodic table associated with its electron structure. The little boy and the fat man. So the little boy was a uranium type bomb. And it yielded about 16 kilotons of TNT. The little boy did. Now, if you look at the difference between the two, the little boy, it weighed about 9,700 pounds. Now, they made a movie on this. I think it was the USS Indianapolis. It was the one that dropped off the fat man to be dropped on Japan because it was so big. It weighed 10,300 pounds. So it weighed, let's say 600 more pounds. And because of that, it had to be transported, by boat to a particular island to be dropped. Now, it had an energy of 21 kilotons. So what's 21 minus 16? 5, yeah, very good. So with just about 600 pounds more, you had a much larger blasting power. So the plutonium, how is plutonium made? So the fat man used plutonium. You might want to write that down just so you know the difference between the two. The fat man uses plutonium, and the little boy used uranium. So you can use less nuclear product. That would be, you can use less plutonium than you would uranium in that bomb, which they dropped on Japan. So you might know where plutonium is made. It's made in nuclear reactors. It's kind of a byproduct says normally plutonium-239 is created in nuclear reactors by the transmutation of individual atoms of one of the isotopes of uranium. Remember we had artificial transmutation and natural transmutation. Which one would this be? Raise your hand. Yeah, this would be artificial because obviously we're doing it in a lab. But the important part here we want you to understand is that the plutonium is the dangerous fuel. It's being made in nuclear reactors, and it's a big reason why there's a lot of different treaties happening in different countries in the world over, like North Korea, associated with nuclear reactors. If you make plutonium and you put it into a bomb, it's a much more aggressive bomb. That means you can put it on top of a warhead, you can use less of it, and it can cause a lot more damage than your uranium. Does that make sense? So the second bomb that they dropped, or that we dropped on Japan, was a plutonium bomb. They tested that one. They expected its results. The first one they did not test. So they weren't sure, but it obviously worked because they have evidence that it did. Eugene? Very good. 16. Now this is kind of a review from, this is a quiz question. So we're in chapter 24 still, and we're moving into chapter 5. So question number 2 comes out of chapter 5. In the atom, what does the electron control? Tim? In the atom, what does the electron control? What does the electron control? Oh, I was just asking if you knew.
The behavior of the atom.
Right, the behavior. So the periodic table is structured based on the electron. That is, you see these groups and you look at the shape of the periodic table because of the electron. We have the alkali, the alkaline, the halogen group. We group things of similar behavior together. Like this is an honors class, it's not like a regular class. So you have shown that Javen's behavior, as far as like his ability to study a little bit, exceeds that of other students. Malachi. Malachi. Yeah, we're focusing. Yeah. So, now last week we introduced the red giant. And we talked about how the wealthy tend to have more to lose. And why do they have more to lose? Why is life harder on the wealthy? Yeah, because they have more to lose. So life is harder typically on the wealthy because they have more to lose. They want to, like, have places they can go, the safe places. They got some place in the mountains, got a bunch of food in it. I call it safe places. There's like shows of this on TV called, what's it called? You know, these people that try to have survival places to live. You ever heard of them?
Oh, there's one place where they live completely away from. We had that in Germany in the TV. There was a
Like bunkers?
documentation about it.
Yeah, there's a show on that. I forget the name of the show.
And there are just like people in it who will probably never come out because they're afraid that the world's gonna end pretty soon. So they will probably never come out until they die.
Yeah. So we've had previous wars like World War II, and in chapter 24 we talked a little bit about fusion, and that is the red giant. Now I didn't discuss fission. I just want to mention it briefly because there's been a lot of hate in the media. Whenever there's a lot of hate, there's always bombs and wars happening. There's still a war happening in Syria. But if we look at the World War II, the bombs that were dropped on Japan, there were two different types. There was the little boy and the fat man. The little boy was dropped first. It had never been tested. It was a uranium-235 bomb, and it looks like this. First, uranium-235 in the little boy. It was dropped first. Looks like this, and what they did, they shot the uranium at itself, which created the nuclear bomb using gunpowder. The Fat Man, they didn't need to do that. They had a blasting cap in the center. The plutonium is just so much more reactive that it caused the bomb to explode very quickly. So, where is plutonium made? How do they make plutonium? How do they make plutonium? Right, plutonium is made in nuclear reactors, and there's a lot of, I guess you would say, regulations associated with this, especially with like North Korea. We want to go investigate their nuclear power plants, because in the nuclear power plant, they can make plutonium. That's where it's typically made. It says plutonium is made from uranium-238, normally created in nuclear reactions by transmutation, that would be artificial, in nuclear power plants. So it's basically harvested out of the nuclear power plant, and then they refine it. Now, what's dangerous about the plutonium is that it's much more reactive. That means it breaks apart a lot easier. The plutonium does. You can have less of it and get a much larger reaction. So the second bomb, even though it only weighed 600 pounds more, it had 5 kilotons of blasting power more. So it caused a lot more damage. That is the second bomb. It was dropped on Japan.
For example, when platinum wire is dipped into a strontium nitrate solution, then inserted into a burner flame, the strontium atoms emit a characteristic red color. You can perform a series of flame tests by doing the mineral. Figure 5.8 shows an illustration of the characteristic purple-pink glow produced by excited hydrogen atoms in the visible portion of hydrogen's emission spectrum responsible for producing the glow. Note how the nature of hydrogen's atomic emission spectrum differs from that of a continuous spectrum.
Okay, so in the text you'll see on figure 5.9, you'll see the spectrum for helium. So how does helium produce this spectrum? No, it has to be excited. So Anna just read that it has to be in an excited state. That means you have to add energy to do this. So when we do like a flame test, when you stick a metal in the flame and it starts to burn, you see the colors, you're adding energy, you're making the electrons excited by changing their energy levels. You're pushing them down into a lower energy level. So it's kind of like an action-reaction type of event. As you push it down, it's taking energy to do that, and then when it's released, some of that energy is going to be converted into this electron, or this spectra that you see. So be aware that every element has a specific spectra. That's how we can identify them. So where the electrons are pushed, the atom can then, I guess you would say, reflect on that. So there's action-reaction. What it took to push that electron down is going to be expressed in the spectra that comes off. So helium can be identified in outer space based on the spectra. That's how we know it's the second most abundant element compared to hydrogen. You can see the spectra out there. Like war or various different types of natural disasters, preppers. So we're reviewing the red giant we talked about last week as far as the sun, and that's fusion. But we didn't talk about the nuclear bombs that were dropped on Fukushima. There were two types. Write this down. That is Japan. There was the little boy and the fat man. So the little boy, what type of nuclear fuel was used for that? Abby, what type of nuclear fuel was used in the little boy that was dropped on Japan?
The nuclear fuse?
Uranium-235. So write that down. Uranium-235 was the first bomb that was dropped. Now, did they test this bomb before they dropped it on Japan?
No.
No, they did not test the first one. They used uranium-235 in kind of like a conventional bomb that had gunpowder, and it shot the two types of uranium at each other, and then it caused a chain reaction and the explosion. That's called the little boy, and it looks like this up on the overhead. So the little boy has this which the uranium is pushed to the other side, causing the reaction to start. Now there are two things needed for a bomb. What are the two things needed? You need a fast reaction and a container it can break out of. If you just have a fast reaction and a weak container, you're going to have a rocket. So it'll shoot off like a rocket. If you have a fast reaction and too strong of a container, what do you have? You have a dud. So the container is just as important as the reaction. You have to be aware of both of them or you're going to get a failure. Now the second bomb that was dropped on Japan was one made with what? Plutonium. Now where is plutonium typically produced? Anybody know?
Lab.
No, it's typically made in a nuclear reactor. So plutonium is a byproduct of the artificial transmutation that happens in your nuclear reactors. Now, what's the problem with plutonium-239? Well, if you drop a bomb with that on somewhere or somebody, it stays around for a long time, has a very long half-life, and it's damaging if you breathe it in or gets in your skin and it affects your DNA. So they prefer hydrogen bombs. These are much more messy than plutonium bombs are. So if you have a country that's making plutonium and they drop it in the environment, you know, we're worried about plastic in the ocean. It's kind of the same thing. You don't want to be dropping plutonium everywhere. It's just really dangerous. Is it as reactive? It's fairly reactive. It's going to be a little bit larger as far as mass, plutonium-239 compared to uranium-235. So it is a little bit larger. Could you get more energy off of it? Most likely. Because you're only using 600 more pounds of the plutonium and you get 5 kilotons of firepower from that just a little bit of mass increase. So be aware that these are the two types of bombs that were dropped on Japan, Corey. And when the bomb was dropped on Japan, what happened to the people?
He got leukemia.
They were vaporized. The people that came outside, they didn't expect a bomb to be dropped on them because planes had flown over them for several months and they thought they were blessed because they weren't dropping bombs on them. So when the plane did drive or fly over and it dropped the bomb, the people were standing outside. They were vaporized and they're called shadow people. You can see where their shadow or where they were when the bomb hit. It just kind of vaporized them.
Can you still see it?
Probably.